What's going on, my friends? We are here for another exciting episode. As always, our binge watch series of the OChem Rockstar approach to discover what's possible for us. What are we going to be doing today? I know you already know. Every time I say that, I'm like, you already know what it is because you can read the title of the lecture. But anyway, I say it anyway. What we're going to be doing here is synthesis. Now, at this stage, what I want to point out is, am I expecting you? Whoops, wrong way. I was wiping some off my computer. Am I expecting you to know how to do this now? Absolutely not, okay? Synthesis, you can imagine here, we're basically in, you know what week we're in? We're in week 4. In week 4, if you were in your class for 4 weeks, there's no way that you would be at this level right now in terms of, in the class, in terms of the amount of knowledge. The amount of knowledge that you've learned in this 4 weeks and been able to retain it, I'm unbelievably proud of you because like I said, we are taking a completely different strategy to understanding organic chemistry to make it much simpler and more effective than what you're going to see in your class. Now, if there's anything wrong with the way it's taught, that's not what I'm saying at all. I'm just saying that this approach, the way that we're doing this with you, the elite students, this helps students basically crush this class so we can condense the material, make it simpler, more effective, and more efficient when we learn. So when we go to our class, we can completely and totally crush it. Now, with having said that again, I would not expect any of you to be able to do this at this stage because that's not what this is about. What I want to do here is start introducing you into what synthesis looks like, how to kind of think about it, and basically what's the sequence going to look like. But once again, I'm going to point this out. We more than likely will not be doing a lot of this just because it's not in this, it's really hard to do in 5 weeks, okay? We can learn the fundamentals, we can learn the skills, we can start crushing organic chemistry, know how to predict products, right mechanisms. Synthesis does take a little bit of time, but there may be something like, Jay, I think I can do it. Awesome, I love the confidence, okay? But here's what you're going to do in a synthesis. Now, what I'm doing here is, this is a more challenging synthesis, but I always kind of drop them on to start off with, is what we want to do here is first, anytime you have a synthesis, there's a systematic approach that you can do. And I also want to point this out, anytime you synthesis, there's a systematic approach and there's typically like one reaction that's going to be the key, or one function group that you can always think of, okay, in this one, the key function group is an alkene, or the key function group is an alkane, or the key function group is something. There's always one in here, okay? And I'm going to kind of walk you through that process. What you first want to do is always number your carbons. You always want to see if you've added, subtracted carbons, or stayed the same. So if I went in here and started numbering my carbons, I can see that on the right-hand side, left-hand side, I started with 3 carbons, and on the right-hand side, I've got 4, okay? What you also want to do with synthesis is you always want to remember, I tell students, remember where you are in the class now. Because sometimes it's overwhelming, like, how in the world am I going to know how to do this? So far, we've learned what? 3 function groups: alkyl halide, alkene, and alkyne. Those are the only function groups that we can use, okay? Those are basically it. Now, there's going to be another synthesis, I think, on here that I'm going to show you at the second one where we can use a different function group. You haven't learned it yet. We haven't talked about it yet. We're going to. But I want to show you how we can modify synthesis. There's not one right way. There are lots of ways. But right now in this one, we've learned 3 function groups: alkyl halide, alkene, and alkyne. So what we're trying to figure out here is to go from the alkane, how are we going to go to another alkane? Well, we have to go through some sort of function group because we can't go from that to that. So what this entails is basically going through here and trying to figure out, like with your reagent list that we've done. So you're going to have a reagent list, you're going to have your reactions, and you're going to get comfortable with your reagents and your reactions, and you're going to get comfortable also with going through specific function groups. So what I'm going to do right now is I'm going to tell you a specific function group series, and I want you to write it down because I don't have it here. I'm pretty sure I'm going to have it somewhere else, but for now it's not in this one, but I need you to write this down, okay? So get a piece of paper, stylus, whatever, something, write this down, okay? I'm going to wait until you get something to write it down. Hoping you're pausing this as well, okay? This is an unbelievably common sequence that you are going to see in almost every single synthesis. I've been doing this a long time now, and I've yet to see this not show up in some synthesis, particularly in OChem 1. Here's how it typically works. You're going to start with, you're going to see it here too. I want you to write this first, and then you're going to see how it shows up later because I didn't do it. You're going to write alkane to start with. That's a function group that you could start with. Alkane. There's nothing on there. Alkane. Write alkane. Then I want you to draw an arrow like you see here, and then I want you to write alkyl halide. Okay, so alkane, arrow, alkyl halide, okay? Then you're going to draw another arrow after that, and you're going to write the word alkene, okay? Then what you're going to do is you're going to draw another arrow, and you're going to draw dialkyl halide. We haven't talked about it, but just write dialkyl halide. Then you're going to draw another arrow. I'm trying to keep track of this all in my mind. Then you're going to draw another arrow called going to alkyne. So this is what it should say. I'm going to try to do it with your visual element here. It should say alkane, arrow, alkyl halide, arrow, alkene, arrow, dialkyl halide, arrow, alkyne. That's what you say. So basically what I want you to see is the main function groups are going from alkane to alkyl halide to alkene to alkyne, okay? That is an unbelievably common sequence that I need you to commit that to memory because you're going to be using that over and over and over again. I'm going to show you, like right now, you're like, well, it doesn't mean anything. I know it doesn't mean anything, but I'm going to show you here, okay? So the first thing you want to do is you want that sequence dialed in your head. That's the thing. You're going to go from alkane, alkyl halide, alkene to alkyne. That is like dialed in. How do we know if we're going to use that? Well, one, that's one of the most common sequences, but two, this is what you're going to do on this one. I started with an alkane and I ended with an alkane. And the way that I did this was I added a carbon. The only way that you know how to add carbons based on where we are as well as where you'd be in your class right now is using an alkyne. Remember that was the last reaction we did where we had a triple bond with an H. We used the NaNH2 to pull off the hydrogen, get a negative charge, and then that negative charge could attack an alkyl halide. Do you remember that? If not, make sure you go back and rewatch that. Okay? But we did that. So that's the only way that we know how to form a carbon-carbon bond very effectively, okay? So when I look at this, what this automatically tells me is I go, okay, I went from alkane to alkane, I added a carbon, the alkyne is my main function group, okay? That's the thought process. But like I said, I am not expecting all of this to come together because I'm throwing a lot at you. You would not be doing synthesis at this stage, only 4 weeks in. But I want to kind of get you thought because I know you are an elite group and I know you all can handle this. And as I said, I'm always going to push you kind of the edge, not over the edge, but I'm going to push you the edge because I'm going to make sure that you're dialed in because I know you have high standards and I'm going to make sure that I hold you those high standards so you can get into your Plan A medical school, okay, dream medical school. All right, so now that we have that, this is what we're going to do. So I'm going to walk you through the forward thing of how we would think about this. There's another thing that you're going to hear about. We may or may not do this. I just haven't figured out all the details on this, but there's something called retrosynthesis. And I'm going to go back here. A retrosynthesis is what I'm going to show you. I'm going to go forward what we've seen. I'm going to take a reaction, reagents, get a product, and then I'm going to go over and over and over again. A retro is where you walk backwards and try to figure out, okay, if I had this, what would be the reagent and the reaction right before it, okay? But this time we're going to go in the forward. So this is how it's going to do. We're going to have that. So in order to do this, if I have an alkane, there's basically one reaction. I'm going to walk you. There's one reaction that we know of. If you go back to the alkanes, I talked about there's one reaction that's useful, and that's a halogenation with bromine and light. So if we look at that, there's only one reaction we do, Br2, and that should be Br2 in light or Br2 in heat. It'll brominate at the more substituted carbon, okay? You can always go back and rewatch that lecture where I talked about taking an alkane, bromine and light will always form a bromine at the more substituted carbon, okay? That's the first one. Now, this is the new focus. Now we say, okay, I went from an alkane to an alkyl halide. Remember the first sequence I told you to write? Now we have an alkyl halide. What can we do with alkyl halides? There's only two reactions, substitution and elimination. Now, how are we going to think about this logically? Since you've never seen synthesis now until I'm showing you, I'm going to walk you through this process and show you actually how much simpler it is than what most students think. So if we think, I want you to think about this logically, not think about, okay, like what reagents are they, what reactions? This is what most students do, like, I don't know all the reagents, Jay, I don't know all the reactions, like, what am I going to do? Let's look at what we have in front of us, okay? Let's just make it simple and look here. So what I want to tell you is in order to go from, you see here that our bromine's at the top of the mountain. And then we've got valleys down there. But if we look at our final product at the top, see how we go up, down, up. So we have that extra carbon that's going out on the side that's attached on what would be considered carbon 3 on that side. The only way you can go from where the bromine is to start substituting on the other one is an alkene. The alkene is the bridge. So if you ever noticed that you're moving down your carbon chain and adding things, you had to have gone through an alkene. That's the only way. Remember, we've done this right now. You can't do a substitution and get that substitution and move over unless you get a rearrangement, right? We've done that as well, but we can't get a rearrangement. So your bridge to go from one carbon to the other is typically going to be an alkene. So we can do substitution elimination. If I come in here and I do an E2 elimination, I can now get my double bond. Why is that important? Because remember we said alkenes, we saw that we can add groups to both sides. So now there's a possibility that we've kind of bridged over and now we can add something. So we went alkane, alkyl halide, to alkene. This is how synthesis works. It's going to be multiple steps. We're trying to go from one to the other, and we're trying to pull all of our knowledge and ultimately get to the final structure. Now, how do you make sense of this? Like I said before, you're going to have your reagent lists. So we have our reagent scheme for alkyl halides. That's the SN1, SN2, E1, E2. We have our reaction or reagent list for alkenes, which is the H2O method, and the reagent list for alkynes is exactly the same. It's an H2O method. Okay, so we have all those, and we're going to use those when we kind of scan through and practice. So now we've gone alkane, alkyl halide, alkene. And then what we're going to do next is we got to go in the next function group. In order to get that is we know the only way we can add carbons is an alkyne. There's a two-step procedure that we haven't talked about. We've talked about some of these reactions. So what can happen here is if I have an alkene, if I take that and I add bromine, I get what's called as I didn't call it before, but it's a dihalide. That was that other term. Remember I said alkane, alkyl halide, alkene, dialkyl halide. So now we have a dialkyl halide. Dialkyl halides allow us to form a triple bond. So that's our bridge between a double bond and a triple bond, okay? Once again, I'm just going to repeat myself because I know synthesis when you first see it can be very overwhelming, can bring on a lot. Most students get kind of a little bit anxious, like, oh my gosh, you're like, how am I going to be able to do this? That's not where we are right now. I also want to remind you the fact that you're not in the class right now. This is a prep course. So we're getting you prepped. So you're going to already see, here's the difference. I want to point this out as well. Most students don't prep before like you are. So if you're kind of feeling a little overwhelmed, like, gosh, like, how am I going to ever do this? Think about this. You're not in the class, you're getting prepped ahead of time. Imagine if you went in the class and all of a sudden you got dropped something like this and you have to figure it out. I know what that's like because that's what it was like for me. It was very overwhelming to think of how am I going to make sense of this. But I want to remind you, the students that prep ahead of time, that start to see synthesis ahead of time, that practice it like we're doing it ahead of time, do exceptionally well on the synthesis because now they know the strategy, they know how to think about it, that it's not all about the reagents in the middle of the arrows, it's about going from functional group to functional group to functional group, okay? So here we're going to go for our dialkyl halide. If we take this dialkyl halide, we can actually turn that into the triple bond, okay? So now I'm not going to go over this full thing here, but what happens is if we use NaNH2, what NaNH2 will do is it'll take that dihalide and just kind of auditorially hear me. It does an E2 times 2. It does 2 E2 eliminations. How does that make sense? Well, we know we can do an E2 elimination with a negative charge in an alkyl halide. So since we have 2 alkyl halides, we can do 2 E2s, and we know every single time we do an E2 elimination, we get a double bond, we get an extra bond. So if I do an E2 followed by an E2, I get an alkyne. But what we're going to wind up doing here on this one is we see we've got a two-step procedure. So what happens here when you do NaNH2 is you get the triple bond, and we get an H. But what's going to happen here intermediately wise is we're going to wind up getting a negative charge on that endpoint, and we've seen this reaction. So like I said, we have not gone over this reaction from the dialkyl halide to here. We haven't gone over it. I don't expect you to know it. I want you just to see the sequence, but we do understand this right here. If I have NaNH2 and CH3, when I have a negative charge, I can do an SN2 with that methyl, and I can wind up adding a carbon there, okay? So we can see from where we started to here, we started with 3 carbons, and now we have 4. We've just added our 4th carbon, and the only way that we can do that is if we had an alkyne as our intermediate. Now, how are we going to go from an alkyne, 4 carbons, to an alkane, 4 carbons? That's the reaction we just learned. Remember we said we could do H2, palladium on carbon, and that'll reduce everything down to the alkane. So that's what a synthetic sequence. You can see it looks not like that big of a deal. It's like, okay, 3 carbons, 4, what's the big deal? There was 1, 2, 3, 4, 5, 6 steps to do something that looks very, very simple, okay? But like I said, we're going to go through some of these things. I'm going to try to build them in. I'm not going to do a lot just because it's not a big part until you get into the course. And sometimes it's hard for me to kind of predict what your professor is going to ask, but we'll drop some stuff in here. This is a common sequence right here, so I did want to at least drop this one. This is a very common one I see. But what you'll be able to do is once you get in your class, your professor is going to give you more stuff to kind of think about. You're going to get really dialed in, but keep this sequence in mind right here. What we basically did was went from alkane to alkyl halide to alkene, and then ultimately to alkyne, and we added a carbon in there and reduced it down, okay? Now this next one I want to show you is there's not always one way, and this is what can be kind of tricky about synthesis. There's multiple ways, so watch what we do here. I'm going to do the same sequence. I'm going to take an alkane, I'm going to go to an alkyl halide, and I'm going to go to an alkene, okay? Now remember this last time we did a dialkyl halide and we did some E2s. Watch what we can do here. I can also come in here and I can do a hydrobrasion oxidation, an anti-Markovnikov, and I can wind up getting an oxygen on the end. Now what I want you to see here is, once again, just forget about the reagents. Look what we've done. I haven't added any carbons yet. So the key feature here is that we have to add a carbon. Here's another way that you're going to see. This is mainly when you get into OChem 2. Sometimes this will show up towards the end of OChem 1, but I want to show you here that if I take that, and we're going to talk about this reaction, I can take that alcohol, what's known as an alcohol, and I can oxidize that to a carbonyl, okay? We'll talk about that later. But you can see here that now I still haven't added my carbons, but if I come in here with a reagent called a Grignard, and that's with a carbon that's negatively charged and it has a metal atom, magnesium specifically, you can see here now that I've added a carbon. Once again, we have not gone over this. I just want you to show you, just once again, this is all about getting the visual element of a synthesis, what it's about. Getting some reagents, going from function group to function group, it's basically a function group transformation. Instead of what we've been doing in each week, it's like, here's an alkene, this is what it does. Here's an alkyne, this is what it does. Here's an alkyl halide, this is what it does. Synthesis says, take the alkane, do something with it. Now, what did it give you? Oh, a new function group. Now take that one, do something with it, take that, do something with it. So you can see we're going from function group to function group to function group to function group. That's what I want you to get out of this, okay? So if we look at this, went from alkane, alkyl halide, alkene, alcohol, carbonyl, specifically aldehyde, back to an alcohol. Then these two steps, what this would be called, I didn't draw them in there, but the first one gives us an E1 elimination. And then the bottom one would be a hydrogenation. So that would give us an alkene, and we reduce that down, okay? So you can see there's multiple ways, but I want you to think function group to function group to function group. It's kind of like taking all of your resources, and now like you have a whole toolbox. Now, like, okay, how can I take these tools and put them in a linear fashion, ultimately get to the final structure, okay? I want to just at least introduce you to synthesis, okay? If obviously at this stage you're like, Jay, I'm not really sure about this, but I have some questions, bring them to the live lectures or bring them to the one-on-one. I can definitely walk you through all of this if you really want to dive in. But once again, I just want to repeat myself because the teacher just saying it over and over again, is that I just wanted to get you introduced to this, okay? And with that, my friends, that's all I have today for synthesis. And until next time, I hope you all have a fantastic day, evening,